we're picking up right where we left off last time and going straight into more with multiplying exponent stuff. So remember last lesson, we did things like x to the fifth times x to the sixth. There's 5x's here, there's 6x's here. So we just added the exponents together and we simplified this to be x to the 11th. Okay, so that was multiplying exponents last time. You're still going to be seeing stuff like that today, but there's one other multiplying like exponential stuff that's going to come into play today, and it's something like this next little example here, where it's like x to the fourth, that's in parentheses, and then there's another exponent sitting outside the parentheses. So in this case, they're cubing that. You can use the property we learned last time, guys, to simplify something like this. So you can always like rewrite it and then use that to combine things together. If you raise something to the third power, that just means you're multiplying it by itself 3 times. So in this case, I could rewrite this as x to the fourth times x to the fourth times x to the fourth. And then I could use last time's property, and I would just add 4 plus 4 plus 4, so that would be x to the 12th. There's 12 x's there. Just like last time, there is a shortcut, so I can avoid writing this out every time to figure out the answer, and I bet a lot of you can see it right now. So if I look at what I started with and what I ended with, notice that this time I didn't add the exponents together, I just multiplied them. 4 times 3 is going to give me 12, which was the answer. So really simply put, that's the shortcut for today. If you've got something with an exponent in parentheses and then they raise that to another power, you can multiply the exponents. It is not always this easy though, and you guys probably could already predict that. They can make it super complicated. So let's look at something like this next one before we kind of generalize a rule and practice. So this next example, it's pretty much the same thing, but they threw a number in front of the x. So like 5x cubed, all of that squared. Just for fun, let's rewrite it just so we can help ourselves figure this out. You got to think to yourself, what does it mean if you square something? Well, if you square something, you multiply it by itself. So this whole thing in parentheses, 5x cubed, I want to multiply that by itself. So 5x cubed times 5x cubed. We saw stuff like this last time. Remember, we just multiplied the big numbers. 5 times 5 is 25. And then we added the exponents. There's 3 here, so there's 6 x's. So the answer would be 25x to the 6th. Now, a common mistake is people will just say, oh, she told me multiply the exponents, so it'd be 5x to the 6th. So people would probably get the x to the 6th part right, but you're probably thinking, well, where does 25 come from? So let me show you one other way to think of this. We'll do it off to the side, then we'll write our rule in. If they give you something like that, where there's a 5 in the parentheses and an x, and we're squaring all of it, you do still multiply exponents, just like we did up here, but if they don't give any part of what's in the parentheses its own exponent, you should write it in first. What I mean by that is the x has a 3 as its exponent, the 5 also has its own exponent, and if they don't write it, you should. It's just a 1. There's a 1 on anything that doesn't have its own exponent. Okay, I like to think of it now, yes, I'm going to multiply the exponents, but if there's more than one exponent, then you just kind of think of it as distributing. Which, that's easy for me to remember because parentheses make me think distribute. So that might help you here. You just distribute the exponent through. So that would be 5, only multiply the exponents. 1 times 2 is 2. And then 3 times 2 is 6. Then I could work out that number and say, oh yeah, 5 squared, that's 25. X to the 6th. And boom, I got my answer right here. And we're going to practice this a lot. So if that was kind of weird, don't worry about it. So the trick for remembering how to get this correct is you should make sure that each base, like the 5 and the x, have their own exponent. before you multiply or distribute through. Okay, so put ones on bases that don't have an exponent written. Then you just think of the problem as distributing the exponent. And we're getting all mathy here, so we generalize it with letters. We love doing that in math. If you've got something in parentheses with an exponent and they raise that to another power, we call this power to a power rule. You just take the base and you multiply the two exponents, m times n. Okay, it seems pretty straightforward, and essentially it is, but the reason these are hard is because every problem is different. So honestly, I mean this wholeheartedly, it just takes practice. I'm going to give you some steps. You should follow them because some of these examples, guys, get pretty crazy. I mean, look at stuff like that. So if you get stuck, use these steps. The first thing that you should do always is distribute the exponent. Which kind of makes sense because in solving for x from last semester, you always started by distributing in those. So do the same thing here. When you distribute the exponent, you multiply the exponents. After that, you want to look to see if you can combine any base terms. And what I mean by that is, we'll give you an example. If you've got like x to the third and x to the ninth, so the bases are both x's, you could always put those together to simplify it. So in this case, I'd add the exponents, and that would be x to the 12th. These get tricky because there's lots of rules. When you distribute, you multiply the exponents. When you're just multiplying, though, like this, you add the exponents. So you gotta like be careful in remembering the rules here. From there, yeah, that should definitely say step 3 and then step 4. But step 3, remember, it's not simplified if you have negative or 0 exponents. So you want to take care of those. Remember that negative exponents, to make them positive, you flip them over the fraction line. So we'll just say kind of flip right there. And then remember from a couple lessons ago, anything to the 0 power equals 1. Okay, and our last step then is going to be to evaluate any of the numbers. And a quick example there, remember we said like, okay, if you got 3 squared in the problem, it's always better to write 9 instead of 3 squared. Okay, use these steps. It's a downfall of what people do on these problems. Use the steps so you know how to approach the problems. All right, let's practice. So number 1, the first thing you should do, if you see the parentheses, distribute that exponent through. So there's only one base term in here, it's just c. So I'm going to do 5 times negative 3 and get c to the negative 15. Obviously can't combine it with anything, and I know to be simplified I cannot have a negative exponent, so I need to move this guy below the fraction line. Okay, so my final answer, I want to show that it's on bottom, so it'd be c to the positive 15 on bottom with 1 on top. Alright, for the next one, so same thing, first step, distribute the exponent. So where I see the parentheses, that happens here. I want to multiply 6 times 2. That would be k to the 12th. There's 12 k's right there. Bring down your times k to the 5th. Now I just need to combine these like base terms, bring the k's together. So there's 12 k's here, there's 5 k's here. Add your exponents, and you've got k to the 17. Okay. Same thing on the next one. So I see the parentheses with the power outside, so I'm going to distribute there. I'm going to bring down my x to the 3rd, and that would be x to the negative 14. Don't move the negative just yet. Combine the terms first. So bring these x's together first by adding 3 plus negative 14. So that'd be negative 11. Then take care of the negative and bring that to the bottom. So it would be 1 over x to the 11. All right. on the back, here's where we slowly start to get a little bit trickier. Do not forget that every single base inside your parentheses has its own exponent. The a obviously has a 4 as its exponent, but the 2 has a 1 there. So you should write that in before you go and distribute that -3. Okay, don't multiply 2 times -3, you multiply the exponents together. So it'd be 2 to the -3, and then a to the -12. Before you ever try to figure out what 2 to the -3 is, your last step, guys, is to evaluate the numbers. So make the exponents positive before you try to do that. So both of these terms need to come down to the bottom for them to be positive. So that would be 2 to the +3, a to the +12. Then I'm going to evaluate. I know that 2 to the 3rd is 8, so I can make it just a little bit better and say 1 over a to the 12th. Aren't these fun? Okay, next one. And again, this just takes practice, so I know there's a lot, but roll with it. First step, distribute. So I have distributing here and here. I'm going to multiply exponents when I do that. 15a is here, 16 here, so I'm going to add them together, and that would just be a to the 31. Okay, I see that this first group is in parentheses, but there's no exponent right here, so that's not going to change. It's going to stay 8, a to the 4th. But I am going to distribute over here with this second group because there's a power outside. I need to give the 3 its exponent of 1 and a exponent of 1. Then I'm going to distribute. So this is going to look like 3 to the -2, a to the -2, and b to the +4. Okay, I distributed. Now I see if I can combine anything. And I can combine the a's. So let's see, there's 4 here, -2 here. If I add, that's +2. So it kind of looks like that. Next step, take care of negative and 0 exponents. So the 3 is the only one that needs to move. So let's see, that would be 8a squared b4 on top and 3 to the +2 now on bottom. And then I know that I can make 3 squared equal 9. So I'm done. Whew, lots of steps. All right, number 7. I don't have any distributing. There's no parentheses. I can combine some stuff, though. So the x's on bottom, I'm going to put those together. So that would be -8 plus -6 is -14. It also jumps out at me right away that I have m to the 0. Anytime you see something to the 0 power, just cross it off. It's just 1. So I only have 19 on top. Now I'm going to take care of my negative exponent, and I'm going to move the x up. So actually everything is on top now, so I'm not even going to write the fraction. It's just 19x to the 14th. Okay, I want you guys to try 8 and 9. Yay. See how you do. I'll check those next time. Number 10, love this problem. Check it out. All this is in parentheses being raised to the 0 power. You would distribute 0 to everything, and that would make everything raised to the 0 power. All of that cancels out. That whole thing just equals 1. Love that question. Wish they all were like that. Number 11 is as bad as it gets on this stuff, so bear with me here. I know I need to start by distributing this power out here, this 3. I'm going to go inside the parentheses, though, and give everything that doesn't have an exponent a 1. Okay, so I have a lot of distributing. Distribute to the top and to the bottom because it's all in parentheses. So this is going to look like 2 squared x to the 9th, multiply your exponents, 4 to the 3rd, y to the -9, y to the 3rd. Okay, next up, combine stuff. So I'm going to put together the y's here by adding. Looks like I need more space here for this. Oops, that should be 2 to the 3rd. Good catch on my part. Okay, so on bottom I've got 4 to the third, negative 9 plus 3, that'd be y to the negative 6. Then I take care of the negative exponents, so I'm going to move the y up to the top. And then lastly is I want to evaluate the numbers. So 2 to the third and 4 to the third, I'm going to figure those out. Oh my gosh, this is so many steps. 2 to the third is 8. 4 to the third is 64. And I'm telling you right now, you can actually make this one step better. You should always look at the numbers. It's 8 over 64. That fraction can be reduced. I can divide both of those by 8. So 8 divided by 8 is 1. 64 divided by 8 is 8. So the best answer is 1x to the 9th, y to the 6th over 8. Ooh, that one's nasty. All right, last one. This is very similar to the scientific notation problem from last lesson if you just rewrite it. So I want to multiply 5 times 10 to the negative 6th, and I want to square that. Again, think what squared means. Well, it just means you multiply it by itself. So you should write this 2 times. That's a hideous 5, but that's a 5. Okay, so write this twice, square it, multiply it by itself. Now it's exactly what we did last time. So remember to bring these together. We multiplied the a values, those first 2 numbers there. And then we brought the 10s together by adding the exponents. That'd be negative 12. You always got to make sure what you have is in scientific notation, and this is not, because 25 is not a number between 1 and 10. So I need to move the decimal over to make it to 0.5. If I move the decimal, I have to adjust the exponent. So remember the trick, I made it smaller. It went from 25 to 2.5. So I need to make the exponent 1 bigger. So that would give me an exponent of negative 11.